All right, guys, welcome to another episode of Cuda Education. Today, I want to go over a very small piece of the conversation, but what I want to do is uh, start with basically what happens when what I want to focus on is the this item here called render to frame, right? Render to frame. This is what's basically giving us the triangle that we are familiar with this application, right? So we have our triangle here, right, in the window, and you guys know if I comment it out, basically we don't get a triangle, right? We which makes sense. We went over that previously. Okay. So the question is where is this render frame to triangle defined, right? And let us attempt to piece together what makes this happen, right? What is the deal behind this render frame to view, right? Render frame to view. So if we go into it's gonna be the hello triangle. We're going to the Metal 4 renderer, and then we go to Metal 4 renderer, right? And then we basically just, what you can do is, search for render to frame, right? Render frame to view, and you will get the function, right? Draws a frame of content to a view's drawable, right? Parameter view, a view with a drawable that the renderer draws. Okay, a view with a drawable that the renderer draws. Um, right. So basically, what it's saying. Right. So it's basically saying, listen, we have the window and everything set up. We have a surface to draw some stuff. We're gonna draw on that view. We're gonna draw on that area that we are allowed to draw on. Right. Just to anchor us, we are in Metal 4 renderer and the Metal 4 renderer file. Right. Um, and that's where the render frame to view is defined, and we were previously in view controller, metal kit view delegate, right? And you guys know that the delegate is really what calls the renderer, right? The mtk view has a delegate, and the delegate is what basically gets the renderer for us, right? So the delegate is a very important part of the MTK view puzzle, and that's what calls the renderer. So we're in Metal 4 renderer, and we're in this file. Obviously my machine is running the Metal 4 renderer, so we're in this file. If I was in the Metal renderer, I assume we would just be in the Metal renderer file. But because we're in the Metal 4, I'm running Metal 4. This is what drives everything for me on my machine. Okay. Just to anchor us, let us also just go to the top of the file. Okay. So one of the things that is important here is that we have Kmax frames in flight. Now, if I drop this variable to 0, essentially the program crashes, right? The window doesn't even come up, right? So the renderer is called, and then because the K max frames in flight is 0, the application crashes, right? It will build, but then when it tries to run, it crashes. Okay, so we'll just run with that for now. Okay, so now we're into render frame to view. This basically, so the first thing we do is we do an if statement of self is missing requirements from view. Okay, and basically what this is testing is, is the surface visible to the viewer, right? Is it visible? Because again, the system is not going to render stuff if it's not visible to the to the viewer, right? So if your monitor can't see it, if it's being blocked or whatever, we're gonna save that processing, right? So basically, if it fails the test where it's not in view, it just returns immediately, okay? And that's that. After we do that, we get into just sort of some bookkeeping, if you will. And basically, what we're doing is, we have to figure out what frame number we're actually working on, and also what is the frame index. So what is the there's a frame number and then the frame index. So sorry, the frame number just increases, every frame basically gets a specific frame number. The frame index now, so this number increases past 3 or whatever, right? It just keeps increasing as the application runs and there are more frames issued. This number increases, right? So that's the frame number. The frame index now is which one of the 3 frames are we actually working on, right? So basically we're rotating 3 frames, right? But we need to know which of the 3 are we actually working on. This is which one of the 3, and then this is just an overall labeling for each frame, each particular frame. But as far as the frame index is concerned, the frame index is just concerned with which one of the 3 frames are we working on, right? And we see here we have a labeling structure here that basically it needs to mark each frame, right? So if you're running your application for a very long time, frame 1253 is gonna be is gonna have frame number as 1253. As far as frame index is concerned, it just needs to know which one of the 3 max frames that we have in flight, which one of the 3 are we currently working on, right? So the frame index and the frame number, this is overall universal, and this is just, hey, which one of the 3 are we working on, right? And we need to label the frames because for debugging purposes and stuff, right? So that is that. The renderer skips waiting for the first Kmax frames in flight frames. There aren't any earlier frames to wait for because they're the first. So if frame number is greater than max frame, wait for the oldest frame in flight to finish rendering before reusing its resources. Okay. This is important. This is important because every frame has resources attached to it, right? And we need to make sure that the frames the frames have been they're finished being used by the previous frame before we start reassigning those same resources to new frames that we want to submit, right? Right. So don't reuse those resources. Don't reuse those resources until the GPU has finished using them, right? This is a synchronization problem, right? It's just when you're dealing with GPU stuff, it's just synchronization problems left, right, and center, right? So we don't want to. Every frame has attached. Every one of the 3 frames has attached to it resources, and we want to make sure we're not reassigning resources, or we're not trying to use resources that hasn't been used or consumed yet by the GPU for the previous frame, right? That's as granular as I want to get right now. See, we have this wait on shared event for earlier frame number minus Kmax frames in flight. This basically gets into, listen, are we done with using the resources for the old frames? Can we now reuse those resources, right? That's as far as I want to get right now for this particular conversation. And then now it has this allocator thing. So this is how prepare to use or reuse the allocator by resetting it. So we're now basically, the allocator is sort of how we assign how we assign instruction and resources to the frame. Okay, but we have to prepare to use or reuse the allocator by resetting it, right? So in order to do that, right, so each frame index has its own allocator. Resetting it means clear out the old commands stored in it so we can record new ones. Okay, so similar to what we're talking about up here, once we are done with the old stuff, we have to reset everything so we could record new commands and stuff for the frame, right? Right, and this is sort of on a per frame level, which is why you have frame index. Again, frame number is just the overall frame number for all frames that have been used in the application. But frame index is just which one of the 3 frames are we dealing with right now, right? So this is on a per frame basis that we have this thing, and we reset. Prepare to use or reuse the command buffer for the frame's commands, right? So begin command buffer with allocator, frame allocator. Okay, so we have frame allocator was assigned as command allocator's frame index. So now prepare to use or reuse the command buffer for the frames command. So now we're trying to put in the commands for this particular frame. Command buffer dot label equals label. I'll leave that alone. I'll leave the labeling part alone. So this piece, we're going to record commands now. Store the recorded command stream in frame allocator's memory. Okay, so that's that. The command buffer is a container for draw calls, state changes, resource bindings, synchronization / presentation steps, depending on the API level. Okay, so that's that for this. Prepare to use or reuse. Right, so create a render pass encoder from the command buffer with the views configuration. So now we are doing a render pass encoder, and we're just putting in the settings that we have, for our particular situation. A render pass descriptor says things like which color texture you're drawing into the drawable's texture, whether to clear it at the start, store actions at the end. Okay, so I'm entering the render pass encoder means I'm entering a scope where I can issue draw calls into this target. Okay, so you're giving a draw context for this frame. Okay, so that's this encoder piece. We'll leave that at that for now. And then we start to get into pipeline information. Configure the encoder with the renderer pipeline state. So we have render pass encoder, set render pipeline state to render pipeline state. Obviously, we'll have to dive into each one of these things and figure out where they're coming from. But for now, just as a quick run through, we just want to at least start the conversation with this stuff, right? So this gives us the draw recipe, okay? So vertex shader, fragment shader, attachment formats, think of things of that nature. Use this set of GPU functions and fixed state rules for what comes next. Okay, so we're basically setting up the situation, right? The pipeline. So we also have to communicate the viewport size. We're going to have some render pass arguments. So the viewport size, this sets the area of the drawable you're drawing into. The triangle vertices are generated in pixel coordinates. The shader needs the viewport size to convert those pixel coordinates into clip space, right? So you have two different coordinate systems. You have the pixel coordinates and then the clip space. And if you get this wrong, basically the triangle looks wrong or disappears or something like that, right? So that's this guy right here, right? And then we get set render pass arguments, right? Right. So this now deals with moving from numbers in memory to the pipeline runs with these inputs, right? So we're now inputting actual stuff into the pipeline. So it's not just things in memory anymore. We're actually well on our way to being able to draw something on the screen, right? But we have to communicate all this stuff properly to the pipeline, the render pipeline, so that we could see something on the screen. So we have 4-frame number with argument table, vertex buffer, triangle vertex buffer as frame index, right? So update the frame buffer for this frame, right? Update the frame buffer for this frame. Update the viewport size buffer if needed, right? Bind these resources so the vertex shader can read them, okay? So that's that. So this guy right here is very important, right? So each frame uses its own buffer slot to avoid overriding a buffer that's still being used. I know this kind of seems a little bit unanchored right now, but we just want to familiarize ourselves with the way how Meadow rolls so that we could revisit it and dive deeper into every piece and get a better understanding. And then now we get to draw the triangle, right? Render pass encoder, draw primitives, MTL primitive type triangle, vertex start 0, vertex count 3. So we have 3 vertices for the triangle. So this is where you request actual rendering, right? So we're going to take the vertices 0, 1, and 2, interpret them as one triangle, run the vertex shader 3 times, right? Rasterize the triangle, run the fragment shader for each covered pixel, write results into the drawable, right? Right. So you've at this particular instance you have requested it, but it still won't appear until submission presentation, right? So you've requested the draw, but it's not, we won't see it at this point necessarily. We requested the draw, and we've given everything that we have. Now I'm gonna assume this guy is what's holding all the information that we have set up before, right? Render pass encoder. We're going to assume that this is what's holding the information that we set up before, right? So we're going to finalize the render pass. No more draw calls for this pass, so we finalize the render pass. You're closing the render pass scope. After this, you can't issue more draw calls on this encoder, right? And then finalize the command buffer. Submit the command buffer to the GPU. So now we set up the command buffer, we have our commands, and now we submitting it to the GPU. We submit to the GPU. We end the command buffer, right? And then we submit command buffer to command buffer Q, command Q for view, right? And then this is the handoff for recorded instructions, actually execute and show. Right, ensure the drawable is ready, commit the command buffer to the queue, schedule presentation to the presentation of the drawable. So basically, if you comment this out, if I comment this out, the triangle will not appear, which I could do right now. So I could comment it out, and basically when I run, I don't get a triangle, right? Because I didn't submit anything. Now notice nothing crashes, right? So we just didn't submit anything. Basically we didn't submit the command buffer, right? So if I remove everything again and then I redo everything, I get my triangle back, right? So that's that, right? But notice nothing crashed, right? We just didn't submit any instructions to the GPU, so therefore we don't get our triangle. Right, signal when the GPU finishes rendering this frame with a shared event. So when the GPU finishes this frame, set the event value to frame number, okay? The next frame uses this information to decide when it's safe to reuse per frame resources. I'm not too sure about why this set value to frame number. Are we testing for frame number up above somewhere? Yeah, I'm not sure about this, signal when the GPU finishes rendering from this frame with a shared event. So we signal and then we I guess we're putting okay, all right. So I guess it says set the event value to frame number. Okay, I guess what this means is that when we're debugging the application and we see this particular event, that we could basically know that this particular set of events, so this particular command buffer, this particular render pass, this particular result from all the things that we did previously, we can associate it with frame number 1053. I guess that's what that means. Okay, so we're signaling when it's done, and we're saying, all right, this event was frame 1053. Okay. And that's it. That's it, guys. Again, we're just doing a quick overview of all that's happening. Guys, I want you to pay attention to sort of the flow of how all of this comes together. So first of all, I'll repeat. First of all, we started in view controller, MetalKit view delegate, right? So MetalKit view delegate is what notice when the app is ready to draw a frame. So notifies the app when the system is ready to draw a frame. So MetalKit view delegate in the view controller, right, is what calls render to frame. Once we get render to frame, once render to frame is called, we basically go to the Metal4Renderer file, and then we get to the render to frame function, and we do all of this stuff. It's important for us to understand just the general flow of what happens. We do a lot of work to basically submit to the command, basically build a command buffer and submit all of that information to the GPU so it can do its work. The GPU has a signal, which we haven't really gotten into signals at all, but basically it's a signal event, shared event, and we attach a value, a frame number to it, so that, when you're debugging and profiling and analyzing, you know what particular frame this one was. Notice that when renderFrameToView is called again, that we now update the frame number, because now we're dealing with a different frame in absolute frames, right? Also remember, frame number and the frame index are two different things. Frame number is the holistic value for all the frames that the application run. Frame index just cares about which one of the 3 frames are we working on right now, right? Is it frame 0, is it frame 1, or is it frame 2? I don't really care about anything else, right? Also remember that this Kmax frames in flight, if I set this to 0, the application doesn't run. Now, if I set it to any other number, positive number, even like 100, it works fine, okay? But if I set it to 0, the application won't run. I'm not gonna do it here because I just don't want to, you know, have the thing, like I don't even get the window is what I'm saying. Like, you know, like how we get our window and we'll just not get anything in the middle. We won't even get the window, right? When we do that. So anyway, guys, that is our discussion for, what do we call this? We call this the we'll call this the render frame to view discussion. I guess that's how I'll label the video. Like, subscribe, you know, get your friends involved in learning metal in 2026. We are already over a week into 2026. Don't let the other 52 weeks go by, or the other 50, whatever weeks, 51 weeks go by, and you haven't learned metal. I'm certainly trying to learn metal. So there you have it, guys. Thank you for watching. Have a great day. This is Cuda Education. Tell your friends, you know, build a community, all of that good stuff. Goodbye.